Now resuming object-oriented part 2, starting object-oriented part 2 on the screen recording. All right, so methods, we just saw in the previous session how the class object attribute is defined outside. This is the class object attribute and how this is defined outside of the method in the class. Also, by convention, we place them before the init method is called for the first time in that particular class. So what happens is with this, now I can do something like call upon the species, right, and then this should return whatever the species is. In our case, it's mammal. So that's about a class attribute, but look at the methods. Let's focus on the methods. Now this is a method that we have created, and methods are, in some ways, we have used the def keyword, right. So methods are functions defined inside the body of a class. Now why are they still called methods? Because they don't exactly fit in the definition of a function, because a function is something that is created to avoid some sort of repetition, so you can keep calling it at multiple places in your program. But methods are something that are used to perform operations with the attributes of our object. So it's restricted by that particular object within that particular class. So methods are essential, however, in what we call encapsulation concept chapter of object-oriented programming paradigm. Now this is essential in dividing responsibilities in programming, especially in large applications. Now you can basically think of methods as functions acting on an object that take the object itself into account through what we call the self argument, right. So in this case, the self takes the object itself into the account. So that is what is letting us call upon this method here, because we are referencing the dog object by calling the instance Scooby, and then being able to take reference of breed, because breed is by associated with dog by the self keyword, right. Sorry, self argument. So let's go through another example. Let's create a circle class. All right, so I'm going to go back over here. Let's create more cells. Oops, not there, but we create more cells here. And all right, so I'm going to create my class and I will name it circle. Inside that, I will type object. Then, so before I instantiate the class with any object attribute, let me define the value of pi, which is 3.14. Now I need to create a circle, and that circle, oops, that's not circle, to instantiate with a circle has a radius. So let's start with that, and this is how we do it, and down D init, and that's it. So inside that, I'll have to have self by convention, and then I will have radius, and the radius, let's say, will have a default value of 1, and after that I will reference it like this. So by doing this, I'm allowing this method to allocate this particular object and associate it with the class called circle. This attribute, this object attribute, is now a part of this major class, right. And I hope you're getting this. Now let's say we will write a function to calculate the area of the circle. Let's just say area of the circle, and that's how we do it. So now this is a method, and this method is restricted only for this particular class, right, and it will return self.radius and multiplied by self.radius pi multiplied by pi. So I could have done something like this. I mean, I could have taken this off, and I could have said actual area is equal to pi r square, and then I could have said print actual area and so on. I'm just trying to reduce the number of lines, so let's put this like this, and this will straight away return us this value of the radius. Now after I did this, I need to, and the radius need to be reset to 1. How do we do that? So I can call another method to do something like that. So they set radius, this is how we do it. Right, so I can create a method on top of an attribute that is already instantiated. Okay, so I do self dot radius is equal to radius. So note that this radius is the same radius as this, right? So I can be sure that the radius value is reset back to this, and after that I can do a method to get radius, like something like this, and always the self keyword is the first one that I write. Unless there are additional attributes that go in, I don't do mention that. So in a previous example we had an additional attribute called name for object. There is only one self, so anything I put after this, it could be breed, name, habits, it could be anything else, and all of this will become a part of this particular object. So going back to our example, I'm going to get radius, and that will return the radius, right? So, and after this I'm referencing the object class to our variable object here, right? So that I can use this in our other, so I can print, for example, print or let's do C set radius is, let's say 2, and I'm passing the value of 2 for set radius, and then once that is done, so I can use this C to set these methods or run these methods, in this case set radius, and then radius is get radius, right? And so notice how I'm running these methods. Okay, so let's see what this does. I'm just going to get rid of extra spaces here, so it looks neat and tidy. Great. So there is a name error we've got, and it says pi is not defined. Let's try and see if we could troubleshoot this. So it says pi is not defined. Let's see what happens if I do like something like this. Okay, great. So I cannot use pi because pi is declared outside of the method, but I can definitely put the value straight away. We'll come back and resolve this, but for now it says radius is 2. When the radius is 2, the area is 12.56. Right, so notice how we use the self notation to reference attributes of the class within the method calls. So be it Flask, you may learn later on, or Django, or run any sort of data science methods or libraries of Python, the self attribute is very important, and we use this to notation to reference attributes of the class within the method calls. So just do go over once again on how the above code works and try to create your own method. As an exercise, see if you can come up with a square where you calculate the area of a square, and you can always reference the formulas in Google, and I think calculating the square is pretty straightforward, and try to come up with methods of your own for a square, for a rectangle, and for a pentagon. And if you're able to do that, let's move on to learn about inheritance in the next class.